this would be an example, and it'll be part of the study guide anyways, of solving a 2-by-2 system of equations with substitution. So what's the first step of substitution? Solve one of the equations for one of the variables, right? There is one obvious choice here, which way too many did not solve for. What should you have solved for here? X in the first equation, because it's 1x. There's a lot of you that actually did that. I mean, you went like this. You said X. Oh, that was. I don't want that. And take that off. Pen. Blue. You solved it for X. And that is not solving for X. X equals 2y. Which should have been the point where you go to the next step, which is what? Substitute into the other equation for that variable. So you would put right here, you're going to put 3 times 2y minus y squared equals 0, which gives you 6y minus y squared equals 0. Right? Now, many, not just this class, but the other class too then, went on to say, okay, that means y equals x over 2, and then substituted that into here. So now you're going to have to square it. I mean, it does not make any sense to do that. And if you don't see that, then that's part of the problem here. When you do substitution, you absolutely want to go for a variable where you don't end up having to divide by anything at the end. And there's nothing sacred about solving for y, right? I don't know if that's, if this had been 2x equals y, probably less people would have made that same mistake. But that's it. So really, even though you can go different ways, and some people did that and ended up getting the right answer, more often than not, it led to not good results. Now, unfortunately, even the ones who did this correctly, almost nobody, maybe 5 out of 55, then solved this correctly. And this is a pretty basic problem to solve. How do you solve this? You take a y out. Y times 6 minus y equals 0. What are the solutions? 0 and 6. That's so basic of algebra kind of stuff that you got to see it, right? You got to see it. Y equals 0, y equals 6. And then how do you find the x coordinates? Because there's actually an x defined. You go back up to the end of the first step, you solve for that other variable, right? So now you go back up here, right? When y is 0, then we get 2 times 0, which is 0. So we have 1.00. And then the other one, you plug in y is 6. I'm writing this like a function notation. 2 times 6 is 12. So that would be 12, 6. So there's 2 answers, right? Not just one. And this should not be such a hard problem to solve. I mean, if all you're saying you can do linear things, that was supposed to be a result of algebra 1, right? Quadratics should be pretty simple to solve, especially one that's not a hard factor. Okay. Right? And again, most of these things we do say as we go along. I mean, it doesn't matter. It doesn't matter. It doesn't matter. Okay, it doesn't matter. You could get the right answer doing something different, but it doesn't make sense. And most of the time when you take that like alternate path, it doesn't end up with good results. I mean, this one has an obvious thing to do. Which variable would you try to cancel with elimination here? You would try to cancel these, right? Because that would just require a multiplication of this by 2, right? So, if you multiply this one by -3, you could still get the right answer. But it really is kind of suggesting to you it's probably better to do this one times 2. Okay. So now if I did it that way, then this line looks like 2x plus 10y equals 20. There was a fair amount of multiplying by a number, whether you did 2 or -3, but not multiplying every term. Like you did the 2x and you did the 20, but you didn't get that. You didn't change that. Right? You got to multiply all three terms by whatever that number is. And now we've got 3x minus 10y equals negative 5. So now we've set up the opposite number coefficients here. So we can add them up and eliminate a variable. 5x equals 15. X equals 3. Right? And then how do you find the other variable? Plug it back into either one. It doesn't matter. I would say most people, including myself, use that one. Right? 3 plus 5y equals 10. 5y equals 7. Y equals 7/5. More than a few put 5/7. Okay, not good. And many turned it into a decimal, which is fine. 1.4. One had a decimal, which was like 1.423 something something. Sorry, that's not right. It was exactly 1.4. If you got it something off than that, there was a mistake there. It should have been exactly that. Okay, next. Use the matrices. First, find the product. Okay, so finding a product, again, I got the sense that most people did in their calculator, and that's fine, right? You can do, if it doesn't tell you to do something in a different way, by all means, you can put it in the calculator, right? Now, this is not a place for inverses, right? It's just asking to do A times B. So just put one in as A and put one in as B, and then do A times B. I'll do it the long way just to have fun, right? So remember, when you multiply matrices, right, you're going across the columns and down the rows. So it's negative 3 minus 4, negative 7. Right? Then it's 4 minus 2, 2. Then it's 0 plus 6, and 0 plus 3. So if you put it in the calculator right, you should have gotten that. I think most did. A lot of problems with this one. It says solve for the x. This is not the place where you have to use inverse matrices. That's completely different. That's when you've got like a times b or a times x, and you're trying to divide or get rid of the a, which is multiplying. This is just a scalar here. So it's not the place to do inverses. You should solve this matrix first. Now, if this was an algebra equation, and you could make that a little x and a little a and a little b, what would have been your first step? Subtract the a, right? So it should have looked like 3x equals b minus a. Many people had a minus b, which of course is going to give you everything's going to be opposite signs. And then, can I divide by 3? So how do I deal with the fact that it's got the 3? Say again? The inverse what? Of 3, right? You multiply by a third. So just do, what we can do is scalar multiplication, right? Honestly, you doing it by hand, if you got to the point and said, I'm going to divide both sides by 3, it would work. But if you tried to do it in your calculator, it won't. The calculator will recognize you doing 1/3 times b minus a. But it won't recognize the, in parentheses, b minus a divided by 3. So let's see. Again, you could put it in your calculator and see what you get. I'm just going to do it longhand anyways. Right, the b minus a, right, in the right order. Negative 3 minus 1 is negative 4. Right, 4 minus negative 2 is 6. 2 minus 0 is 2. 1 minus 3 is negative 2. And then I'm going to multiply all of that by 1/3. So that gives me negative 4/3, 2, 2/3, negative 2/3. Right. And then the last one, when is a matrix multiplication not defined. A lot of the answers I got here were like, when is it that you can't solve a system of equations when the lines don't cross or something like that? That's not at all what this is talking about, right? This is just talking about we don't have a system of equations. We just have two matrices to multiply, and sometimes that doesn't work. And the right answer to say is that when the columns of the first matrix match the rows of the second matrix, this works. When the columns of the first matrix don't match the number of rows in the second matrix, it doesn't work. Something that just says the rows and columns don't match up is not accurate enough, because actually, you know, if you reverse, that could mean this set of columns and that set of rows. I mean, you got to say it means that matrix and that matrix. Or some said it flat out like that. Some showed this kind of thing and said that's what needs to be matched. Most that did it that way gave me an example where it works and an example where it doesn't work, and that was pretty clear. Or just say, you know, the columns of the first matrix have to match the rows of the second matrix. Like this one here, right? These two columns, if I was trying to do my across the columns and down the rows, right? -2 times -2, 0, 1 times 0, and now there's nothing to do the multiplication with. So this has to be the same number as that. Okay, questions? Domande, preguntas. Okay, so let's see. Next time we're going to have a test. As usual, if you do better on the test than you've done the quiz, I'll overwrite the quiz. The study guide looks like this. I'm going to go through and do somewhat of a review. Yeah. When's progress reports? What? When? The 9th? Not likely. I mean, I will probably have them graded on the 8th, but I don't know whether I'll have them sent to the printer yet. It usually does take me till the evening. Ours is second block. I mean, I'll try, or I could just wait and give you your progress report on the next class period, and then you could have it in there, if that's what you want. I'm giving 3 tests that day, you know, functions, and then you guys, and so it's a lot of grading. And from what I see, I don't know. This one, like when you do matrices, it's a lot of writing sometimes. But it's actually, if in the end you use the calculator, it may not be that much to check. You know, I mean, there's not much for me to check other than your answer at that point. Right? I'll try to go back and forth on this. Boom. Solving systems of equations, 2x2 systems of equations by substitution and elimination. Right? We did that. Going over the quiz, we just did that. Check, check. Okay. If the problem says solve by substitution or solve by elimination, you got to do that, right? Solving it by some other means just is not going to be worth anything. There's other problems that just say solve by any method, and then by all means do whatever you want. Right? When we solve 3x3 systems by any method, that could include back substitution. Do you remember when we did that? Okay, let me take this off. So we had 2 ways that we did that. I'm trying to go through here and do 7, 3. I think it's 7, 3. Right? Right? This kind of process. So it'll be something that is set up for you. It's row echelon form. You could either do this back substitution to solve for it, or how else do we solve 3x3 systems? We turn the 3x3 system into a matrix equation like we did in that homework problem. I mean, that ought to be your instinct on it. Because really, it gets too complicated. I mean, really, on a 3x3 system, something like, well, even that one there. I mean, there is ways to do this with just regular old processes, right? You could solve the first equation, let's say, for z. And then you substitute for that in the other 2 equations. And now you'll have a 2x2 system of equations, which you can solve more easily by substitution and elimination. Right? So you can do those processes. the row operations that we showed, how did we find an inverse? By doing row operations? I mean, you could do that if you wanted to, but realistically, that's when you want to pull out your calculator and do the matrices. And it's so easy, and if you're just careful about the way you enter it in, you're going to get it right. And remember, that process will work for any order of matrix. What do I mean by order? Yeah, I mean the rows times the columns, right? That thing. Okay, let's go back to this. Go back to this. It's not practical. That's okay. So check. Decompose rational expressions by the method of partial fractions. And that one we did in the homework already. If I go back to, we did that one right here. Right. Remember, this is what they're trying to tell us with their distinct linear factors, quadratic factors, right? If you've got linear factors, then after you have factored the denominator, which was step 2, then each linear factor gets a constant in the numerator. If you have repeated linear factors, then the first you're going to have as many partial fractions for that one factor as the power. So like this one is trying to show you a repeated linear factor. It had this px plus q to the first, then it had px plus q squared, and it would have to go all the way up to whatever was that highest power. Then you'd have one more term, and we're never going to see that. You know, you might see 2, but that's how you would do it. Okay, and then what do you do when you've got a quadratic factor, something that can't be factored further? Then you use bx plus c. You got to make that a linear numerator for the partial fraction, like we already showed in the homework. You know, once you get it set up like that, there's process and details you've got to get straight, but at least get it set up correctly. Okay, next. So that checks off decomposition. Okay, 5. Given equal matrices, solve for the variables. Okay, page 561. Right, that was the one in section 8.2. 8.2. Right, if you've got equal matrices, what do you know about the entries in each matrix? I just said, if we have equal matrices, what do you know about the corresponding entries in the matrices? They're equal, okay? Is that the word you're looking for? So you can see here, 16 equals 16, 4 equals 4. Okay, but this is 5 equals 2x plus 1. So solve for the variable if you know that the two matrices are equal. So you'll get a, some size of a matrix where you're going to make an equation and solve for the variable. That's it. Piece of cake. So we're going to check off on that one. Okay, simplify matrix expressions. Right, that's the one in 8.2, basic stuff. I mean, even that can be simplifying a matrix expression, right? But it could also mean like these things here, where you're given the matrices and then told to do these kinds of operations, right? And again, unless it says do it by hand, which it won't, you could do that in the calculator. Right? You could just store this as the matrix A and store that as the matrix B, and then on the main screen do 3A minus B. Okay, what helps for the partial credit is, you just, show what you entered in the calculator or something. Now, the next one is solve a matrix equation like was on the quiz, something like that, like was on the quiz or like that. Solve this like an algebra equation, and then put it in the calculator, do whatever you have to do to solve. And if you go back to the that's the simplify expressions, solve matrix equations, which at that point, you'll see when you go to those problems, right? Those are not the ones where we're solving AX equals B by using inverse matrices. Right? That's not it yet. That's just the ones like we had on the quiz. Right? Evaluate a matrix expression. Okay, that's kind of the same thing as this. I think actually what that is, the difference between those two is this. Okay, we're on this already, right? This would be the, that's the simplify. I think one of them, and the other, I mean, they're pointing to different problems, so you'll see which one. And then the one that didn't actually have it, didn't define it as A and B, they just gave you the matrices that simplify these matrices. So, I mean, if you want to call them A and B, you could do that, but it won't be like here's an A matrix and here's a B matrix. Okay, and so that gets us to multiply matrices. Now, I think actually I probably solve matrix equations 27 to 34. Let's go to that page 561 and see what that one is. No, I know what that one is. Oh, so to solve the systems of equations by any method to include back substitutions, right? These problems right here are the back substitution, the one we just talked about. These here are by using matrices. It says any method. So that's where we actually solve using matrices. So this last one is multiply matrices. Pretty much like the homework problem said, just multiply them. And if it doesn't work, say why it doesn't work. Right? Say why are you getting this error message if that's the way you're doing it. So that's it. So I'm not planning to do anything else. I mean, I'll leave you to work on this. If you have questions, you can let me know. I'll be here every day before and after school between now and then, Saturday. There'll be a video of this, if you want to go back and see exactly what we thought we were going to be getting out of this. You could do that. Remember all the videos we made of every lesson. They're right there on the website. You could rewatch it if you don't have uncertainty about a thing. Okay. And I'll leave that up, but it will be sent out and posted to the website. I don't know why this does that.